This is 4.6, day 1, part 1. We are going to graph the cosecant and secant functions in this lesson. Remember, the cosecant and the secant are the inverse functions for sine and cosine. So if you're able to graph sine and cosine functions over the last couple days, then this assignment should be rather easy for you. So we're going to start off with graphing the cosecant function, and we're going to graph the parent function. So you first graph the traditional parent function for y equals the sine of x. So I'm going to graph that in blue, the sine, y equals the sine of x. The parent function for the sine function has an amplitude of 1 and a period of 2 pi. So then I'm going to just graph that in blue. So I start with 0, and I go to 2 pi. I split up in 4 equal parts. So halfway is pi, halfway again is pi, and 3 pi over 2. I'm going to purposefully go another revolution in my sine function, so you can get a little bit bigger picture of what the cosecant function looks like. So I'm going to add on another revolution of 2 pi. So when I add another 2 pi, I finish at 4 pi. Halfway between 4 pi and 2 pi is 3 pi. Halfway is 5 pi over 2 and 7 pi over 2. So I'm going to make 2 revolutions. Remember, the sine function starts in the middle, goes up, middle, bottom, middle. There is 1 revolution. I'm going to continue another revolution. So I'll continue the pattern. Up, middle, bottom, middle. This blue function represents my sine function. Now I'm going to go a step further to actually graph the cosecant function. With cosecant and secant, we are going to draw vertical asymptotes at where the function is undefined. So they're going to be like the zeros on this axis. So the asymptotes are going to occur here at 0, pi, 2 pi, 3 pi, and 4 pi. So I'm going to drop a vertical line down. There's my first asymptote, x equals 0. I'm going to drop another vertical asymptote at x equals pi, x equals 2 pi, x equals 3 pi, x equals 4 pi. All right. Now the actual cosecant function I'm going to have in red. And for my way that I remember this is I go to each of the, what I call the hills between the asymptotes. So in the first asymptote set between 0 and pi, there's a hill that goes up like this. What you do is you go to the top of the hill, and you're going to inverse it or reciprocate it. So you're going to go in the opposite direction, and you're going to create these, what I call parabolas. So there's the first piece of our cosecant function. And we just continue between each of the asymptotes, and we just make these parabolas. We're in the opposite direction from the hill. So here's the bottom of the hill, go the opposite direction. Then go to the next asymptote between 2 and 3 pi. Go to the top of the hill, which is at 5 pi over 2. Parabola. And then the last one, bottom of the hill, parabola. So the actual cosecant function is the red pieces of the graph. The blue and the green pieces of the graph help guide us there. And that's how you graph a cosecant function. Pretty okay? All right, let's graph the next one, which is the secant function. The secant function is the reciprocal of the cosine function. So we're going to do the same exact process again. We're going to graph that reciprocal function, the cosine function, as its parent. Draw the vertical asymptotes, and then draw those what I call parabolas. It's not correct math vocabulary, but it's the way I remember it as a student, and I try to teach you some of those methods. Okay, so we'll stick with the same colors again. So we had blue as our parent function for the cosine. The parent function has an amplitude of 1 and a period of 2 pi. And we'll do 2 revolutions again. So 0, 2 pi, split up that revolution to 4 equal parts. Halfway is pi. Halfway again is pi over 2. Halfway again is 3 pi over 2. There's 1 revolution. Add on another revolution of 2 pi. So now we're over here at 4 pi. And an extra line, don't I? 4 pi. Halfway is 3 pi. Halfway again is 5 pi over 2. And 7 pi over 2. So I've now created my increments. Now cosine function, I say starts at the top of the amplitude. If it was a reflection, it would start at the bottom of the amplitude. So here's the top at 1, go to the middle, to the bottom, to the middle, to the top. There is 1 revolution for our cosine function. We'll continue the pattern again. Middle, bottom, middle, top. Now my asymptotes are going to start at a little different place. If you remember the difference between a cosine function and a sine function, all the differences is a translation, left or right, pi over 2. So when we had that previous example, the asymptote was at 0. Where is this one going to start at? Pi over 2. So my asymptote is at, first one is at pi over 2. 3 pi over 2. 5 pi over 2. 7 pi over 2. Now I'll change to red, which is truly the secant function. So we go to those hills, the tops and the bottom of the hills, go the other direction, and draw parabolas. So I'll start here between pi over 2 and 3 pi over 2, which is at pi, and flip it. Again, at 2 pi, go to the top of that hill, and flip it. Make the parabola. At 3 pi, flip it. And then I kind of have a half of a flip here, and a half of a flip there. And there is our secant function. Those are the parent functions for cosecant and secant. Now if you remember, sine and cosine had changes from the parent function. You can change the amplitude. You can reflect it. You can shift it up or down and left and right. You can change the period. These are also true. So on the next slide will be one more example, and I'm going to change some things so you can see what that looks like.